Now, in the previous section, we've added this basic logic to the collision, which checks if the ball itself is outside the perimeter of the rectangle which surrounds the brick element, then we can determine that they haven't collided. Now we need to add a more complex logic to it, so we're going to change it a bit. I'm going to paste some code and we're going to discuss it. Now, the code that I pasted, although it looks scary, it isn't so scary. It's supposed to make the reading of the physics code much easier, given that we have a name for each one of the borders. So I've created a left border, a right border, top border, and bottom border variables for the hit element. The hit element will replace the brick element, which we used in the last section, because check collision function more general, since we're going to use it on the paddle as well. So left border basically takes the x value, takes the width of the element, and divides it by 2. This way, we'll get the left border. The right border, same thing. We take the x value and we add half the width of the hit element, and we get the right border. Top border, bottom border, same thing. Now we have the previous ball, left border, previous ball, right border, previous ball, top border, and bottom border, and the current ball, left border, right border, top border, and bottom border. Now the main logic we need to add here is similar to the one that we had in the previous section. So if we create a similar logic, we have this, which means if the ball left border is smaller or equals to the right border, and the ball right border is larger than the hit element left border, and the ball top border is smaller or equal to the bottom border, and the ball bottom border is larger or equals the top border, once all these statements are true, then the ball is inside the rectangle of the hit element. So we're going to return true here, and we're going to return false here. So if all these statements are true, then it means that the ball element and the hit element have collided. Otherwise, they haven't collided. So we've recreated the logic from the previous section with our current variables. Now we're going to add some new logic, which is supposed to determine where exactly the ball hit. This is important to us so that we'll know how the return angle should be. For example, if we hit the hit element at the bottom, the y speed should reverse. So if the ball was going up, hit the hit element at the bottom, the ball is supposed to go down. If the ball hit the hit element on the right side, it means that it was going right. It hit it on the right side, and now it's supposed to go left. These basic tests should cover all sides of the hit element. So even if we hit the top right corner, the logic from hitting the top and the logic from hitting the right should both work, and then the ball will go up and right while it was going down and left when it was hitting it. So let me just paste the logic here and we'll discuss what exactly is happening. I've added this code, which I've marked here. As you can see, what I'm doing here is testing each one of the statements which appears in the if statement above, while testing the previous location of the ball. So for example, if the ball top border is smaller or equal to the bottom border, it means that the ball's top part is inside the rectangle's bottom part. Now we want to test the previous location. If the previous ball top border was larger than the bottom border, it means that in its previous location, it wasn't inside the bottom part of the rectangle. So that means that currently, in the current tick, the ball hit the bottom part of the hit element. So if that's the case, then the ball element should go down. So ball element dot up equals false. Now again, like we did in all the previous collisions, we need to fix the location of the ball so that it wouldn't appear as if the ball entered the hit element. In order to give the movement a more natural look, we cannot let the ball or any other part overlap another element. So if we reach the position in which the ball overlaps the hit element, we need to fix it immediately to give it a more natural look. So the same thing here. If the ball bottom border is larger or equal to the top border, means that currently it's in the top of the hit element. If the previous ball bottom border was smaller than the top border, it means that previously, in the previous tick, it wasn't there. So it means that in the current tick, the ball element hit the top of the hit element. So ball element dot up equals true, and the same goes for the right side and the left side of the hit element. After we do that, then we update the last x and next y of the ball element so that the logic above will not reiterate in the next tick. Basically did all the required fixes. We moved the x and the y in order to avoid any overlapping, and now we need to update the last x and next y so that this logic would not reiterate in the next tick.